A single furnace run processes a whole batch of wafers at once, and every wafer in that batch has to come out identical. Same oxide, same film, same diffusion, which means the rack holding them has to keep each one at the same temperature and the same spacing from the first slot to the last. A silicon carbide wafer boat is that rack, a slotted carrier that holds dozens of wafers on edge through the heat, staying clean, staying straight, and holding the spacing that keeps the whole batch uniform. Made from recrystallized silicon carbide, the boat needs no sintering aids that could leach out, so it stays clean in a process where a trace of metal ruins the wafer. It holds that purity where quartz slowly devitrifies, releasing no particles into the slots it cradles. Silicon carbide keeps its strength past 1600 degrees, well beyond the point where a quartz boat begins to soften and sag near 1200. And it resists the hydrofluoric and hydrochloric process chemistries for far longer, standing up to those gases beyond 10,000 hours where quartz would be etched away. It stays dimensionally stable under load at temperature, so the slots do not spread or sag and the wafers keep their spacing run after run. And its thermal expansion sits close to the films grown in the furnace, so the deposits bond cleanly instead of cracking off. Clean, strong, and steady where the process runs hottest. Processing 100 wafers at once creates a problem the boat has to solve. The wafers on the outside of the batch see the heat first, while the ones in the middle lag behind. A silicon carbide boat conducts heat far better than quartz, so it carries warmth into the center of the load and narrows the gap between the hottest and coolest wafer. The spacing between slots, the pitch, is set so the gas and the heat reach every wafer face evenly. Stability over time matters as much as conductivity. A quartz boat gradually bows and its slots drift after enough high-temperature cycles, tilting the wafers and skewing the process. The silicon carbide boat holds its shape, so the slot the wafer sat in on the first run is in the same place a year later. The batch stays uniform because the rack stays true. The matched expansion pays off on every ramp. Because the boat grows and shrinks at nearly the same rate as the wafers and the films on them, the whole load heats and cools as one. So the thin layers just grown are not stressed loose as the furnace cycles. The boat protects the very deposits it helped create. A boat is built around the wafer and the furnace it serves. Diameters follow the standard wafer sizes, from 2 inches up through 6, 8, and 12. While the slot count runs from a couple of dozen up past 100, and the pitch between slots is set to the process, tighter for throughput or wider for uniformity. Orientation follows the tube. Vertical boats stack the wafers in a column for a vertical furnace, horizontal boats lay them across for a horizontal tube. Slot count, pitch, tooth shape, and the end plate and handle details are each cut to the tool. So a boat drops straight into an existing furnace and holds the wafers exactly where the process expects them. In a low-pressure chemical vapor deposition run, a fully loaded silicon carbide boat carries the whole batch into the tube, where a precursor gas lays a thin film onto every wafer at once. Because the boat conducts heat into the center of the load and holds each slot at its set pitch, the film grows to the same thickness on the outer wafers and the inner ones alike, so 100 wafers come out matched. The high purity keeps the deposit clean, the corrosion resistance carries the boat through the reactive gases unharmed, and the matched expansion keeps the fresh films from cracking as the load cools. Drawn out at the end of the cycle, the boat comes away with its slots still level and its surface unclouded, where a quartz carrier would have bowed or devitrified after the same service. The wafers it held all carry the same film, and the boat turns straight around for the next load. Steadfastly, one slotted ceramic rack keeps an entire batch identical through the heat, the backbone of a furnace that has to treat 100 wafers as one.